Download this code and get free GPT-4o from codegive.com, link in the description below. Sure. In Java, threads are the smallest unit of processing that can be scheduled by an operating system. Synchronization is a mechanism that ensures that two or more concurrent threads do not simultaneously execute some particular program segment, to prevent data inconsistency and ensure thread safety. Why synchronize threads? When multiple threads access shared resources, like variables or data structures, it can lead to inconsistent data or unpredictable behavior. Synchronization helps in maintaining data integrity by controlling the access of multiple threads to shared resources. Key concepts of thread synchronization. 1. Monitor. Each object in Java has an intrinsic lock, or monitor. A thread can acquire the lock associated with an object to gain access to synchronized methods or blocks. 2. Synchronized methods. You can declare a method as synchronized. This means that only one thread can execute this method on the same object at the same time. 3. Synchronized blocks. You can synchronize a block of code within a method, which is more flexible than synchronizing the whole method. 4. Volatile variables. While not a synchronization mechanism per se, declaring a variable as volatile ensures that its value is always read from the main memory, not from the thread's local cache. 5. Thread safety. Using synchronization helps in making your code thread safe, which means that it functions correctly when accessed by multiple threads. Example of synchronized threads. Let's look at an example where multiple threads increment a shared counter. We will use synchronization to ensure that the counter is updated correctly. Explanation of the code. 1. Counter class. This class has a private integer count that is shared among threads. The increment method is synchronized, meaning that if one thread is executing this method, another thread cannot execute it until the first thread finishes. 2. Counter thread class. This class extends thread and takes a counter object as a parameter. The run method contains a loop that calls the increment method 1000 times. 3. Synchronized example class. In the main method, we create a counter object and two counter thread instances. We start both threads and call join to wait for both threads to finish before printing the final count. Running the example. When you run the above code, the output should consistently show that the final count is 2000, regardless of how fast or slow the threads run, due to the synchronized nature of the increment method. Conclusion. Synchronization is crucial when working with multi-threaded applications in Java. It helps prevent issues related to concurrent access to shared resources, ensuring thread safety and data consistency. Always consider the performance implications of synchronization, as it can introduce overhead and potentially lead to contention if not used judiciously.